This is the last part of three parts video on consolidation and settlement. It will be about settlement computations. Now it comes to the computation, the calculation. All right. So how do we calculate the amount of settlement? Remember earlier, we need to know the amount in order for us to later on we want to make sure the settlement happen first before we go there. So we need to know what is the maximum settlement that will happen at that place. We want to make sure it happen before we go and put our building there or road. So to know what is the amount of the settlement, we need to know at least these three information. So it says here, analyze consolidation test data. Where is this consolidation test data from? It is from the lab test or SI report. Okay, some of you may have seen some SI report or soil investigation report. In the soil investigation report, if you or the engineers has specified consolidation test to be done, so you will get this information. Yeah, you will have all this information. The first information that you need for you to calculate is what we call the pre-consolidation pressure. So this pre-consolidation pressure, PC, you need to know from the lab test. The second information from the lab test or report that you need to look for is the what we call initial void ratio. Initial void ratio at overburden pressure, at the present overburden pressure. Okay. And number three, you need to know compression index. This is compression index. This is recompression index, CR and CC. All these are from the lab report or the SI report, the soil investigation report that you hire soil investigation contractor to do. So especially if you are engineer, I know we have a few engineers in this class, you will need this to do the computation for your design for your settlement estimation, and also for your other related design later. For example, you want to improve the soil by using vertical drain. So you need to know what would be the different settlement if you use vertical drain and without vertical drain, or with more vertical drain and less vertical drain, for example, or you use other methods, whatever. This information are required. Okay. Next slide. So this is what happened when settlements still happen when you already put the building. So we want to make sure that we want to know what is the settlement that will happen. We want to make it happen before we put this building. So in this case, probably there was no settlement analysis. So that's why this happened. They do not wait for the soil to settle before they come in and put this building. This is the result of that mistake. So what test we use in the lab? It is called odometer test, or simply consolidation test, right? It's very simple, the test in the lab. But we are interested in the result, not the test, right? Not the test. How they do the test, that the testing technician or the engineer will do the test. But we need to know what is the result of the test. But basically, what is tested in the lab is, you can see here, usually, just for your information, this is the soil sample, and you use loading here again in the lab to press and to see what would be the load and the settlement. And when you load, there will be some settlement, and you want to see what would be the what do you call it, the relationship between the loading and settlement and time. And then from there, we will acquire the related information that you need just now to check or to estimate the settlement. This is an example of a chart provided in one SI report or lab report. Okay, you can see from this chart of the report, it already give you what we call the data number one that we need, which is the PC, which is the pre-consolidation pressure. Okay. Also, it gives you the CC, the compression index, right? Also, actually, the recompression index down here, the CR. But if you are an engineer, you are expected to know how to draw this curve, right? Or at least understand, because you may need to interpret this data, or you may be asked to calculate this PC and CC and CI and so on. But if you are a designer for soil improvement, you just need this information. Once you have got this information that has been verified by the tester and an engineer, then you can use the information to what they call to proceed with the settlement calculation. This is just basically the step 1, 2, 3, 4 is basically to show you how to get this figure. All right, get this figure. So this 1, 2, 3, 4. I just keep this one. This is the detail. All right, 1, 2, 3, 4, 5. Okay. And from the report, also you will get what we call the void ratio that we need in the calculation. Void ratio of sample from various depth before consolidation test, usually taken as the average depth from all depth. Usually in calculation, we take average. Okay. Remember, when we drill into the ground, we take sample from different depth, right? From 1 meter, 2 meter, 3 meter, as we go deeper, probably more sample, more clay sample, if there are clay. If there are no clay, no need to take sample. The reason we take clay sample is to do this test, to do the consolidation test. We don't do consolidation test for sand. We do consolidation test only for clay. So if there is sand, there's no need to take the sand for this test. So you're wasting your money. You pay the contractor for no use. You don't need to use the soil for this test. So the void ratio is a volume of void divided by volume of solid. Remember? So this is the void ratio. And the CC and CR, just now we already the slope of curve from the chart. Right? Usually they are already provided in the report. If you have to calculate, it will be this slope and this slope. Now, there will be a lot of times, a lot of situations you don't have SI report. What are you going to do? I mean, your boss is pressing you to come up with certain estimation of soil settlement. So based on, so we need to use a previous, what do you call it, data and empirical works done by previous engineers, scientists, and testers. If you don't have that data, settlement can still be estimated, right? But of course, if you have the data, your settlement estimation will be more accurate because of you are using the actual data from the actual site that you are going to construct your building. But if you don't have any data, settlement can still be estimated by using Atterberg limit. Still, you need some data, but a simpler that data can be acquired from a more simple test like Atterberg limit and moisture content. Right, moisture content easy, right? You take sample, put in oven, take out, you know what is the moisture content. Atterberg limit is you just spend 10 minutes in the lab, you roll some soil, you get the liquid limit and plastic limit, right? So that is a simpler test. Then consolidation test, because consolidation test will take at least 1 week for you to complete the test, longer time. So in this case, let me see. First, if your, remember just now, you want to know whether your soil is over consolidated or normal consolidated. So from Atterberg limit and moisture content, you know it's over, or because you don't have a PC, so you don't know. If you have a result from consolidation test, you know because you have PC. Now you don't have a PC. So if it's over consolidated, if the liquidity index is less than 0.7. That means if the PI, which is the liquid limit minus plastic limit, is less than 0.7. And this plastic limit and liquid limit test, it can easily be done in the lab. You take sample and you go to the lab and you can do quick. Then you can get the liquid limit and plastic limit quickly in the lab. Now you know already, you can decide whether they are over or normal. Next one, the void ratio. The void ratio is usually moisture content multiplied by specific gravity and divide by 100, right? Specific gravity doesn't range very much. It's between usually between in the range of 2.65 to 2.7. So very small. So void ratio you can get from moisture content. The CC, the compression index, is again moisture content divided by 100. The recompression index is moisture content divided by 1000. So now you have got all three information that you need to calculate your settlement. Or there are more empirical data that you can refer to. For example, Das in his book recommended that CC equals to this formula. That means that is a compression index, a compression index. And again, a recompression index was proposed by again Das and National Highway Institute using these two formula. So you can estimate them, even though you don't have the consolidation test. So now, how do we estimate? So this is the computation. So based on those data just now, you are able to estimate the settlement, right? So this delta is the settlement. Equal to H. H is the thickness of the clay. The CC just now, remember, from the test or from the empirical works. Then E naught, same thing, This one here from your chart just now. Remember the chart, the graph, the P, the final pressure and the present pressure, right? The P naught. The final pressure means the pressure after you put the road on the soil. The present pressure means the PO means there is no road or building yet, which is the present situation. Then you will get this. What is the estimated settlement? So let's say you have a SI report, a soil report. Then you will go and look for the CC, or all those information from the P naught and so on, and E naught from the chart. All right. If you don't have data, I already told you that you can get from these empirical works. And also you need to decide whether they are normally consolidated or they are over consolidated. In case of over consolidated, you need to find where is the pressure. You need to read from the chart, the pressure from the chart. Where is the pressure, right? From the PO diagram. What is your final pressure? What is the existing pressure and what is the final pressure? And this curve here you can see is the previous maximum pressure. This one is from the report, right? Previous maximum pressure. This is again in case you have XI report. This is where you look for in the report information. Okay, this is the actual computation of a pressure diagram from actual test, actual project in Penang, in the mainland. All right. You can see the one here is over here is the present, the PO, the present pressure into up to 10 meters below the ground without having any project. The green one here is the pressure we expect it to be after the project is completed. Future. This pink one here is the previous maximum pressure. Right? You can see the previous maximum pressure somehow, you can see at this level between 0 and probably 1 meter above, below the ground. At 1 meter below the ground, the soil over there has experienced even higher pressure than what we propose now. See, this is what we are proposing now. This is what we are proposing now. But the soil here has experienced, because this is pressure, right? This is pressure. Almost 50 pressure instead of what we propose now is about maybe 42. Even with the new road. Without the road, the pressure now is even less. It's about maybe about 10, less than 10, maybe 8. No pressure. But interestingly, the soil here, this level here, and up, this level, was exposed to very high pressure before. What could have been the pressure? We don't know. Most likely flooding or the site. We expect that place was flooded long time ago. So basically that's the thing. But as you go deeper into the ground, so this pressure, what do you call it? More than 2 meters below the ground, meaning the soil has not been exposed to higher pressure than what it would feel now from the proposed project. So this, in this situation, you need to, meaning the certain at certain depth, you need to calculate okay, I got info from Fan Yongfei. He said his Guanhua power supply was cut. Okay, I understand. No problem. Don't worry. He can refer to my to our recording later on. And so that means there will be two sets of calculation. One is over consolidated, and the other one is pre-consolidated. Meaning you need two set of analysis. So that's all difference. So that's how you decide on what formula to use to estimate the settlement. Okay, and next slide is all right. So settlement computation. So this is in case of over consolidation. Okay, when the location is over consolidated, and this is the formula. If the area is over consolidated, but our future pressure is still less than the PC, or the less previous maximum pressure the soil has experienced. But remember just now, there are also cases when there are two cases here. Down here, the PF is higher than the PC. Up here, the PF is smaller than the PC. So there are two different formula. So we use two different formula here. And if the P final more than higher than PC, so this is the formula. Slightly longer formula, but all the information in your unit is the same. The CC, the CR, the E0, the PC and the P0, PC and P final, the same thing. It's just that how you arrange the formula again. That is all. But the basic formula, the basic information will still be the same. F. Okay, now remember just now that the H in the formula we have got H. H is the thickness of the clay layer, right? So for more accuracy, what we usually do in calculation, we will divide the layer into a few sub layers, right? So calculation can be made separately for each sub layer. Usually we will provide the sub layer up to 3 meters. Of course, if you have a smaller layer, probably it gives you a better result, but you need more calculation, right? But these days, with the help of computers, probably you can do it faster. And then we use a pressure measured at center. Whatever information, data that we refer to is at the center of the soil. For example, we talk about this layer. Okay, first let us talk about the whole layer. Let's say this is the whole layer. So the information you will take is in the middle. If you take this layer only, the information, this is information, and this one, we take the information at the center, this one, info at the center. So we use information from the center, the value from the center of the layer in our calculation. That means if our layers are shorter or thinner, that means you will have more calculation and more information. That's why we expect it to be more accurate. That is all, right? In this case, we divide into 3 sub layers to do the calculation. So this is example. Example, in this example, we want to compute or calculate primary settlement of normally consolidated clay due to fill load. Fill load is this one here, granular fill. So basically, in this case example, later on you can go on your own for this example. This is the embankment, the new that we want to do calculation. So we have a sand layer, we have soft clay layer. This is, we need to calculate the settlement from here to here. What will settle? What will be the settlement? How long? How much? 1 meter? How much, right? Want to know the settlement. So the primary settlement of normally consolidated clay to be calculated, and time for 90% primary settlement to occur if clay coefficient of consolidation CV is, if this clay, the CV is also from the SI report. Remember just now I mentioned about the soil report, the soil investigation report. You can get this CV or coefficient of consolidation from the report. So that's why it's very important for design engineers to get the SI report if you are dealing with settlement. It will give you all the data for you to do the calculation. Otherwise, it will be just empirical assumption, and so many assumptions. Too much assumption will probably cause you what they call it inaccurate estimation of the situation. Right. So this is the step of the calculation. Step 1, calculate P naught and delta P. Meaning you need to draw the PO diagram. Calculate PO, means PO is the pre-consolidation pressure. Calculate means you draw the diagram, right? Okay, in this case, of course, P at ground level is 0, all right? At the bottom of sand is 65. And at the bottom of clay, let me see here. At the bottom of clay, is 78. Basically, these are the chart that you draw, okay? This is in calculation. The different, delta P is difference in pressure. That means your chart for P final, PF, right? Different in pressure. So in this case, basically, this is the PF. So it's easier if you, so this is the PF. If you draw a chart like I showed earlier, this is P naught, this is P0, and then this is P final, pressure final. Right? So this PF here is actually the P naught here plus delta P. Delta P is the additional load from the field, which is gamma H. Right? The field is like that. It has certain height, and we know what is the density of the field. So gamma times H. So that will be the delta P. So P naught plus delta P, you get P final. This. Oh. Right. So that will be a chart. Yep. So that's a diagram. That's a diagram. draw pressure diagram. This is the P naught, this is the P final, this is the delta. Step 3, from diagram, okay. The P naught at the middle of clay. So from this diagram, we know where is the clay layer. We know this is sand up to, this is clay. This is the clay layer. So the middle of the clay is somewhere here. So then we will get what will be the P naught at the middle of the clay, and the P naught at the middle of the clay, and also P final at the middle of the clay. Step 4, we do the calculation. We use the formula. Remember, this is the formula. We just plug in H because it's 2 meters, right? CC is 1.1 from the report. E naught is 2.096. P final is 209. We just calculate it's 209. P naught is 72. And then we got the delta H as 0.329 meter. So that is a calculation for delta H. Right? This is assuming, in this case, the clay is normally consolidated, right? Normally consolidated. So the total settlement is 0.329 for normally consolidated clay. Okay, now we know the total settlement, which is about this height, 0.3 meter. For time calculation, this is the formula for how long it will take. Time equals to T multiplied by H, vertical, okay, square, divided by CV. Remember CV, I told you, it's from the report, from SI report. So that's why SI report is important. Otherwise, you cannot estimate the time. So in this case, we consider single drainage. Single drainage means if we press the clay, water will only move one way, up or down. If the water can move up and down, then there will be, you need to divide by 2. Okay? But in this case, single drainage, the thickness is 2, so the H is also 2. But if the thickness of the clay is 2, but the drainage can go up and down, that means 2 divided by 2. So it's 1. H become 1. What is the situation when there will be double drainage? Double drainage when below the clay there will be sand again, above the clay is also sand. That means water can escape into the sand both ways. But in our case, the water can only escape upward, cannot go downward. That's why it's a single drainage. So in this case, for 90% consolidation, T90 equals to the capital T. This T is actually what they call it a coefficient for 90% consolidation. That is fixed, 0.848. So T90 equal to capital T, which is fixed here, 0.848, multiplied by 2 square divided by coefficient of consolidation from the SI report, then we have got 2021 days or 71 months or 5 years. No, 5.9 years. Right? So 5.9 years is very long. You cannot wait. Or maybe some situation you can wait, but most of the time these days you cannot wait. But at least you know the total settlement, which is 0.3 something meter, and how long it will take, which is 5 years. But sometimes this information is good. If the result is, let's say, 20 years, so you don't have to worry too much. Maybe the structure will not be there for 20 years, maybe just 10 years, so it's okay. But if the structure will be there for 50 years, meaning after 6 years, there will be 300 settlements. So there will be some, you decide whether you can deal with that.